Hi, welcome to this Corbettmaths video. In this video we're going to look at the GCSE Further Maths topic of completing the square, and we're going to look at how we can use completing the square to find the minimum points, so the minimum point of a graph, a quadratic graph, but also how to find the minimum value of functions. So that's what we're going to look at in this video. Now before we do that, here we've got an expression. We've got x squared minus 4x plus 19. I'm thinking back to your Key Stage 3 maths or even GCSE maths, you may have substituted values of x into expressions such as these. So for instance, if x was equal to 2, we would do 2 squared, so we do 2 squared, subtract 4 times 2 plus 19. And if we work that out, we get 2 squared is 4, and we're going to take away 4 times 2, well that's 8, and then we're going to add 19. And then if we do 4, take away 8, that's minus 4, plus 19 is equal to 15. So that means that whenever x is equal to 2, this expression, this x squared minus 4x plus 19, will be equal to 15. We may have substituted other values. Perhaps we may be substituting a negative value, such as negative 10. And if we wanted to work out what this was, whenever x was equal to negative 10, we would do negative 10 squared minus 4 times negative 10 plus 19, and we'd work that out. So negative 10 squared, that's negative 10 times negative 10, that's 100. And then we would take away, well, 4 times negative 10 is negative 40, so we're taking away negative 40, and then we would add 19. And if we do 100, take away negative 40, well, that's 100 minus 40, that's 140, plus 19 would be 159. So whenever x is equal to negative 10, this expression would be equal to 159. So that means that we should be fairly confident of being able to substitute in values into this expression, so substituting values of x into this expression. But what if we wanted to find the lowest possible value for this expression? So in other words, if we were to pick a certain value of x and we substitute it in, what's the smallest possible answer that we could get? Okay, so looking at it, what if we try 0? So if we have x is equal to 0, well that would be 0 squared is 0, take away 4 times 0, that's 0, plus 19, that would give us an answer of 19. So x squared minus 4x plus 19, if x is equal to 0, would give us an answer of 19. Now is that the smallest value for this expression? So perhaps we might want to try another value. So perhaps we might want to try 1. So try x equal to 1 is equal to 16. So that's even smaller than 19. Now is there a smaller value for this expression? Well, if x is equal to 2 is equal to 15. So whenever x is equal to 2, the expression would be equal to 15. And then if we were to try 3, then we would find that we get an answer of 16, so it's going back up. And if we were to try the decimal numbers, such as 1.9 or 2.1, none of them are as low as 15. So 15 is the minimum value for that expression. It's the lowest possible value we can get for this expression when we substitute in a value for x. Now that's quite time consuming, and if I wanted to find the minimum value for this expression, I wouldn't want to have to use trial and error to find what value of x I'm going to substitute in to get that minimum value. And if, for instance, I needed to substitute in 78.5, I might not even get there in time. I might actually take the whole exam to find that. So what we're going to do is we're going to look at and see how we can use completing the square to work out the minimum values of these expressions really quickly and really easily. And it's going to make it a lot easier to find the minimum values of these expressions. Now actually, the interesting thing with GCSE Further Maths is another approach as well that you'll learn later using a topic called differentiation. But in this video we're going to focus on how we can use completing the square to do it, because the specification, what the exam board tell us we have to cover for GCSE Further Maths, they say you have to be able to use completing the square to find minimum points of these quadratics, but also later on you need to be able to use differentiation as well. Okay, so let's have a look and see how we can use completing the square to find the minimum value for this expression. Okay, so to find the minimum value of this expression, we're going to use completing the square. So make sure you know how to use completing the square, and if you need to go back to Corbettmaths and watch the video on completing the square, feel free to do that. So if I wanted to do completing the square in this, the first thing I would do is I'd open up my brackets, I would put an x, and then I would look at the coefficient of the term in the middle, this x, and the coefficient is minus 4. We half that gives us minus 2. So we do minus 2 and then close brackets squared. So that's how you start off with the completing the square. Then you're going to take away whatever this is squared. So whatever this is squared, you always subtract that. So minus 2 squared is 4. So we're then going to write subtract 4, and then we're going to put the plus 19 on the end. So if we were to do completing the square on this quadratic, we would get this, and then we can simplify these numbers on the end. So we'd then get x minus 2, close brackets squared, and then we've got minus 4 plus 19, or minus 4 plus 19 will be equal to 15, so plus 15. Okay, so if we completed the square on this quadratic, we would get x minus 2, close bracket squared, plus 15. Now that we've done completing the square, we can actually use this to help us find the minimum value of this expression really easily, and we can figure out which value of x would give us that minimum value really easily as well. Okay, so to do that, the first thing we need to do is we need to look at this bracket, and we think, well, we've got something squared. Now, if you square something, well, if you square a positive number, you get a positive value. If you square a negative, you get a positive value as well, because remember, a negative times a negative is a positive. But if you square 0, that's equal to 0. So whenever you square something, the smallest possible answer you can get is 0. So the smallest possible answer we can get whenever we choose a number to substitute in here will be 0. And that's whenever x is equal to 2. If x was equal to 2, we could do 2 subtract 2, which is equal to 0. So that's 0. And then we've got squared, and then we've got plus 15. 0 squared is equal to 0, and plus 15 gives us 15. So that means the minimum value of this quadratic would be 15, and the value of x that we would use would be 2. And the key thing is that when you do complete the square, you've got this bracket squared. The smallest possible value you can have is 0, so then you can figure out what the value of x would be. You could then figure out, well, if that's 0 squared, that's 0, and then you would then just have the number on the end. So whatever this number on the end would be that minimum value for the quadratic. Because it's plus 15, the minimum value for this quadratic is 15. If it was plus 27, it'll be 27. If it was subtract 8 or minus 8, then it would be minus 8 would be the minimum value, and so on. And that's it. Okay, so we're now going to look at some exam style questions on how to find the minimum value of some functions and the values of x at which they occur. Okay, so let's have a look at our first question. So our first question says, and I've written these in the same style as some questions that have happened on the GCSE Further Maths exam, and then we're told a function is defined by f of x equals x squared minus 6x plus 20. So we've got this function of x, and part I says use completing the square to rewrite f of x in the form of x plus a close bracket squared plus b. So we want to do completing the square on this. So we've got our x squared minus 6x plus 20, and we want to do completing the square on this. So let's do that for part I. So to do that, we're going to open up our brackets, we're going to put our x, and then we're going to halve the coefficient of the x term, which is minus 6, so half that would be minus 3. So minus 3 close bracket squared. Then we're going to take away whatever this is squared. Well, negative 3 times negative 3 is 9, so we're going to take away 9, and then we've got plus 20. Now, if we do minus 9 plus 20, that's equal to 11. So we get x minus 3, close bracket squared, and then we've got plus 11. And that's it. So we've written it in that form. We've done part I, so we've done completing the square. Okay, and then if we continue, we're then told part II, hence find the minimum value of f of x and the value of x for which this minimum occurs. So that's what we want to do. We want to find the minimum value of this f of x. And we've done completing the square and we've got it in this form. So that's fantastic because we can use this completing the square to help us find the minimum value of f of x. And we can think of the value of x which it occurs, which will be 3. So let's have a look at this. So we've got f of x, what we've just got is equal to x minus 3 close bracket squared plus 11. And we've been asked to find the minimum value of this f of x. So the minimum value, well, that'll be whenever the bracket's equal to 0, because obviously a positive squared is a positive and a negative squared is a positive. But if this bracket's equal to 0, then that will give us 0 squared, and 0 squared plus 11, or 0 squared plus 11 would be equal to 11. So the minimum value of f of x would be equal to 11. That's the answer there, 11. So the lowest possible value of f of x would be 11. And remember, whenever you do completing the square, the bit on the end here will be the minimum value of that f of x. Okay, and then part B. Part B says find the value of x for which this minimum occurs. Well, the value of x which it occurred, well, to make the bracket equal to 0, x would be equal to 3. So x is equal to 3. So that's the value of x that we would use to get the minimum value for this function. And that's it. Okay, so just to recap, in part I, we need to do completing the square. And part II, we're asked to find the minimum value of f of x. So we just looked at our completing the square. We made the bracket equal 0, and then that gave us 0 squared plus 11. So the minimum value for f of x would be 11. And then part B, the value for x which that would occur would be 3. To make the bracket 0, x would be 3. And that's it. Okay, so we've looked at where we've used completing the square to find the minimum values of some functions. Now let's have a look and see how we can use completing the square to find the minimum points of some graphs. So if you've got a quadratic, remember a quadratic graph in the form of x squared plus something, where it's a positive x squared will be a U-shaped parabola, it will have a minimum point, so that turning point at the bottom whenever the gradient's equal to 0. And you can use completing the square to find the coordinates of that point. Okay, so let's have a look at this graph, y equals x squared plus 4x minus 12, and let's use completing the square to find the coordinates of the turning point of that graph, the coordinates of that minimum point. Okay, so let's do completing the square to begin with. So if we had x squared plus 4x minus 12, if we do completing the square on that, we'd open up our brackets, we put x, and then we would do half the coefficient of x, and half of 4 is 2, so plus 2, close bracket squared. We then take away whatever that is squared, so 2 squared is 4, so we're going to take away 4, and then we've still got our minus 12 on the end. So then this would be x plus 2, close bracket squared, and then minus 4 take away 12 will be minus 16. So that means that y squared plus 4x minus 12 is the same as x plus 2 close bracket squared minus 16. And if you were to expand that bracket, so to multiply by itself and to take away 16, you'd get that. So we've just used completing the square to get our quadratic in a slightly different form. Now we can use our knowledge of what we've looked at in terms of finding the minimum points to find the coordinates of the turning point of this graph. So to find the coordinates of the turning point, well, let's consider this. A positive squared is a positive, a negative squared is a positive, so the minimum possible value of y here, if we were to substitute in values, would be whenever this bracket's equal to 0. So that means that if the bracket's equal to 0, the minimum value of y would be minus 16. So that would be the y coordinate, minus 16. Now in terms of when does that minimum occur, well that minimum will occur whenever the bracket's equal to 0. So that would be whenever x is equal to negative 2. Because to make the bracket 0, x would be negative 2. So x would be equal to negative 2. Then if you do negative 2 plus 2, that's 0. Squared is 0. Take away 16 would be minus 16. So that's the lowest possible value you can get for y. Whenever you let x equal negative 2, y is going to be negative 16. So in terms of the graph, that's going to be the coordinates of the turning point. So that means the coordinates of the turning point would be negative 2, negative 16. Okay, so now let's have a look at some exam style questions on this. Okay, so here's an exam style question. We've been told a function is defined by f of x equals x squared minus 4x plus 11, and we've been asked to use completing the square to rewrite f of x in the form of x minus a close bracket squared plus b. So we need to do completing the square on this. So let's do that. So part A, we're going to do completing the square on this. So we've got x squared minus 4x plus 11. To do completing the square, we're going to open up our brackets. We're going to write down x. We're then going to half the coefficient of x, so half of minus 4 will be minus 2. Then close bracket squared, and then minus 2 squared is 4, so we're going to then take away 4 and then put plus 11, and then if we simplify this, we're going to get that's equal to x minus 2 close bracket squared, and then minus 4 plus 11, well minus 4 plus 11 will be 7, so plus 7. So that means that f of x would be equal to x minus 2 close bracket squared plus 7. So that's part A, just writing this in the form of x minus a close bracket squared plus b. So we're just done completing the square on that. And then part B says, hence, so we're going to use this, write down the coordinates of the minimum point of y equals x squared minus 4x plus 11. So rather than having the f of x is now y, so we're now considering the graph of y equals x squared minus 4x plus 11. So this is this quadratic, this U-shaped graph, and we want to find the coordinates of the minimum point. So to find the coordinates of the minimum point, well, we've got x minus 2 close bracket squared plus 7. And the lowest possible result, the minimum possible result of this will be whenever the bracket's equal to 0. And if the bracket's equal to 0, that means that x will be equal to 2. So x is equal to 2. So 2 minus 2 is equal to 0. Squared is 0 plus 7 will be 7. So that means the minimum possible value for y would be 7. If you substitute in any other value of x into here, you would then get an answer bigger than 7. So the minimum possible value for this is 7, or just looking at the bit outside of the brackets, 7, we know it's going to be 7. And that'll be whenever the bracket's equal to 0, so whenever x is equal to 2. So the coordinates of the minimum point will be 2, 7. And that's it. So in terms of that U-shaped parabola, the turning point will have coordinates 2, 7. Okay, let's have a look at another one. Okay, so here we've got another one. It's a very similar question where we've got f of x is equal to x squared minus x plus 7. And we've been asked in part A to use completing the square to rewrite that in that particular form. And then part B, write down the coordinates of the minimum turning point, or hence write down the coordinates of the minimum turning point. Now hence is very important because we're using completing the square there, and we couldn't just start using calculus to do that. Okay, now also I've put this question in on purpose because all the other questions so far we've had nice coefficients of x where it's either been 4 or 8 or minus 2 and things like that. But here we've got this minus 1x. So we're going to have to then, we're going to have a fraction whenever we're doing completing the square here. Okay, so part A, we have x squared minus x plus 7. And we're going to do completing the square on this. So let's open up our brackets, put our x. Now we're going to half the number in front of the x. Well, it's minus 1 because it's minus x, that's minus 1x. And half of minus 1 is minus a half, so minus a half, close brackets, squared. Then we're going to take away whatever this is squared. So we're going to take away a quarter. And then we're going to put the number on the end, that plus 7 on the end. Okay, so that means that we've got x minus a half, close bracket squared. Now remember, it is a calculator paper, the GCSE Further Maths exam, so you can just type this into the calculator, minus a quarter plus 7, or you could just do minus a quarter plus 7 would be 6 3/4, because you'd add a quarter to get the 0, and then you'd have 6 3/4 left, plus 6 3/4. Okay, and you could write it as a top-heavy fraction if you wanted to. As a top-heavy fraction, it'd be 27 quarters or even 6.75. So that means that f of x in that particular form here, and whenever we use completing the square, will be x minus a half, close bracket squared, plus 6 3/4. Or as a top-heavy fraction, 27 quarters or 6.75. Okay, and then part B. Part B says then, hence, write down the coordinates of the minimum turning point. So we need to obviously use this because it says hence. So obviously here we've got x minus a half, close bracket squared, plus 6 3/4. And that's what y is equal to. Y is equal to that. So we want to find the minimum possible value for y. So that's whenever x will equal a half. So x will equal a half. And if x is equal to half, we get a 0 in the bracket. So 0 squared is 0, and then plus 6 3/4. So y would be equal to 6 3/4, or 27 over 4. So that means the coordinates of the minimum turning point will be a half and then 6 3/4. And that's it. So they're the coordinates of the minimum turning point of that graph. And that's it. So in this Corbettmaths video, we've looked at the GCSE Further Maths topic of completing the square and how to find the minimum values of functions using completing the square and the values of x at which they occur, and also how to find the minimum points of graphs, those quadratic graphs in the form of x squared, where it's a U-shaped parabola, and how to use completing the square to find the coordinates of those minimum points. And that's it. And I really hope you found this video useful. Thank you. Cheers. Bye.